Good morning, good afternoon, everyone. This is Ricardo Casanovas. Welcome to our new webinar today. Let us wait a few seconds, or a couple of minutes, to wait for other people to join, and we get started. Thank you. Okay, so let's get started. Again, welcome everyone. My name is Ricardo Casanovas, CTO and co-founder of Linke. And with me I have Guillermo Torres, one of our product development leads. And today in this new webinar, we'd like to talk a little bit about how to do DevOps for your SAP Business Suite running on the AWS cloud. Before we get into matters, let me just give a short introduction about Linke, our company. Linke is a company that helps enterprises on their cloud journey with Amazon Web Services. We do have a professional services practice that we help customers deploying, migrating, planning, and operating and automating their SAP applications in the cloud. But as well, we have a small portfolio of products that extend and enhance SAP workloads and applications running in the cloud. Linke is an AWS Premier Consulting Partner, holding the SAP competency, migration competency, and DevOps competency. We've been AWS partners since 2012, and since then we have grown our business to be 100% focused on SAP infrastructure and technical configuration running on the AWS cloud. Just to show a few numbers about our company. We've been, as a company, the first non-global system integrator to be AWS Premier Partner in combination with the SAP and the migration competencies. Our managed services team manages daily over 200 productive SAP instances. And in the past year, we've done more than 100 SAP migrations to AWS Cloud for our customers. We do serve customers in over 13 countries, maybe mostly in EMEA. And we like to highlight that our team of engineers is both proficient on SAP and AWS. We don't have, as a company, two different teams for different technology stacks, but we do have a unique team that is knowledgeable of both skills. And our product portfolio that includes our 6 products are the ones that we're showing now on screen. First of all, we'd like to highlight the AWS Connector for SAP, which is an ABAP add-on certified by SAP that allows you to integrate your SAP workloads with the AWS cloud. For those interested in this product, we have a few webinars already that we've done introducing and showing the functionalities of this product. Also, we have Memory, which is the backend interface for SAP HANA databases running on AWS to allow them to do backups and restores directly to Amazon S3, which is also certified by SAP as a product. We have a high availability solution for SAP running on AWS as a serverless orchestrator that manages all the failover and failback of SAP application services. And for the matter of this webinar today, we will get a little bit into details about the SAP Automation Platform, which is the set of automations and scripts that we have built at LinkedIn in the past years, and we are continuously building and enhancing, that allows us to automate the deployment and operation of SAP infrastructures on AWS. Additionally, we have some pre-installed SAP systems ready to be used and available through the AWS Marketplace, which are good for non-production workloads, for testing, sandboxing, and training, for example. And last but not least, Elastic SAP, which is the integration of AWS autoscaling for your NetWeaver application service. As our certifications and competencies as company, we'd like to highlight as well that since the end of 2019, we've been awarded by SAP the SAP DevOps, Hosting Operations, and SAP HANA Operations certifications, which reflect our focus and our track record, helping customers and SAP customers in this case, running in the cloud and managing their operations. So let's get into matters for the contents of our webinar today. And I'd like to start with a small definition of what we mean for DevOps. What you see here on screen now is the definition that you can find on the Gartner website about what is DevOps. For us, we like to highlight that DevOps is about rapid IT service delivery, is to be faster, to adopt Agile, and emphasize on the collaboration and of the different teams within the IT department, and emphasize that it's a culture and it's a process that needs to be implemented. But of course, this DevOps requires some technology to work, especially automation tools that can help you program and operate infrastructure dynamically. But above all, what we are trying to achieve with the use of DevOps for SAP is try to move from manual operations in the data center for our SAP infrastructure to managing code that will represent our infrastructure, and that we can and that we can automate, test, and monitor throughout the different life cycle phases of our infrastructures. So, what do we mean by DevOps for SAP? The SAP stack can be divided in 4 layers, as you can see in the screen. In the bottom layer, we have the AWS infrastructure. So there is the region, the availability zones, the VPC, networking settings, and the EC2 instance settings, the storage, etc., etc. On top of that, on our EC2 instances for our SAP environments, we'll have the operating system configuration, the settings, patch level, versions, security, hardening, etc., etc. On top of that, we'll have our SAP basis layer that will include all the SAP software and the SAP database configuration. That is how the instances are installed, how the database is configured, and on the settings at basis level from the SAP instances. And on top of all this, we'll have the SAP application, where we will operate with the clients, customizing and app development in our environments. Just for clarification, the upper layer, the SAP application layer, it's out of scope of this webinar today. We don't intend to talk about DevOps on the development of SAP custom software. For this, there's I would say other tools, just like the Solution Manager Change Request Management, or Advanced Change and Transfer System from SAP that allows you to implement DevOps or run your development cycles between dev quality and production using a DevOps approach. Today, we will focus on the 3 underlying layers from the AWS infrastructure up to the SAP software configuration, including database and operating system level. So all these for what? Well, the benefits we expect to get from applying DevOps to our SAP infrastructures on AWS is, first of all, focus to let our IT teams focus on value for our businesses, and relieve the work from manual, repetitive, and low-value tasks. Just to put an example, if we need to update a kernel on an SAP system and we have a 12-system landscape, we'll have to do that 12 times manually. Well, we expect that thanks to DevOps and automation, we'll be able to do that automated and not having to do the repetitive tasks over and over again. And of course, this will lead to an expected increase in efficiency and reliability for our operations. Thanks to standardization and homogenization and the capacity of testing our infrastructure, we will reduce errors and the uncertainty of the work we are doing manually, and therefore we will increase the efficiency and the reliability of our environments. And most of it, of course, last but not less important, we expect to reduce the costs, especially the cost of operations of our SAP infrastructures. Let's put some KPIs. We all love the KPIs from applying DevOps into our environments. I'd like to highlight 4 of them. First one would be faster deployments. You can go from over 8 weeks to get a new SAP landscape deployed to roughly 2 hours of time to get that infrastructure deployed. So that would lead us to 99% more speed in deploying infrastructure for our SAP landscapes. We will have also an increase of 80% in operations, in day-to-day operations. Here, thanks to the automation and the capacity of doing parallel work over multiple SAP environments and different environments, we are able to achieve up to 80% of acceleration in the operations. Of course, we have lower operation costs. We have measured in our engagements with different customers around 30% savings, thanks to the standardization and homogenization of the infrastructure, and as well a significant reduce of cost in the audits to check and validate that our infrastructures are compliant with business expectations. And of course, we have happier teams, teams that can focus on value-added tasks and innovation and things that are more useful for the business, and spend less time doing repetitive tasks and low-value work. So how does it work to set up DevOps? So first of all, we need an automation toolset. As we mentioned before, DevOps relies on automation, and we need an automation toolset that will support and give us the speed and velocity that we require. This automation toolset can be an existing automation toolset, or there are plenty of offerings in the market. But what is important is that we get a toolset that allows us to operate automatically and have a continuous delivery and continuous integration pipeline where we can move on our software. Okay. On top of that automation toolset, we have some continuous integration. We need the capacity to work in collaboration to do the development and to manage our source code for our infrastructure and our operations and our software configuration. We will need some continuous testing, so we need to test everything that we do needs to be tested early, and needs to be an automated test so that we don't get slowed down in the developments that we do. We need continuous delivery to automate, build, and move those changes through the pipeline, through our development, sandbox, quality, pre-production, and production environments. And of course, something that is very important is we need to monitor all phases and have tools that would allow us to monitor everything, and that will enable us to act fast and correct any errors that might happen. Think of this as kind of a wheel that needs to be started, and that's a cycle that it's repeating over and over, following agile principles. So, talking a little bit more specifically about the Link's SAP Automation Platform, which is the automation platform that allows SAP customers to describe and maintain their landscapes in a friendly way, we like to say. It includes infrastructure as code in the form of Terraform scripts for automating the AWS services and infrastructure. And as well, we rely on Chef software for the configuration and operation of SAP software and the informants of compliance. Okay. Our automation platform allows us to check changes before they are applied into production. We can maintain our own versions and different versions of our infrastructure so that we can have some version control and version management of our environments. And it allows for the creation of Chef policies, which are the customer custom layouts of their SAP infrastructure. For those of you that might not be familiar with Chef software, our Link SAP Automation Platform includes the automation capacity for SAP instances and SAP software in general. So we can automate the deployment and configuration of an SAP S/4HANA environment, for example. But each customer can apply its custom policies that will reflect the personalization of this S/4HANA environment for the current environment. So we understand that for customer A and customer B, we will have different representations of an S/4HANA environment, both valid and both meeting the requirements of both customers. And this is what our platform allows each customer to customize and personalize what their specific environments will look like. Having a picture around the architecture of the Link SAP Automation Platform, all the automation, being Terraform scripts or Chef software or all the automations and source code resides on Git repositories of source code, which are feeding our SAP Automation Platform, and that can also feed automation platforms from specific customers. Within our SAP Automation Platform environment, it resides in a separate AWS account and includes all the Terraform scripts, S3 buckets with all the SAP software required to do the automation, and as well the Chef Automate instances based on AWS OpsWorks to manage and control the software configuration and compliance. The SAP Automation Platform connects to the customer AWS account using IAM roles and doing an assumed role in order to be able to operate and connect and automate tasks within the customer's AWS accounts. And the different EC2 instances where we are deploying and configuring our SAP software are connecting through the Chef client software to our automation platform to get all the configuration and all the tasks that need to be executed in order to enforce the process itself. All this platform is accessible through a web access. It's browser-based, and we've built a custom front end to make more user-friendly and more easy to use the definition of the specification of the different SAP settings for a customer. What's included today in our SAP Automation Platform? So today we are supporting all the services you can see in the screen from AWS in terms of automating, creating, and operating AWS services. So basically you have VPC, networking through routing tables, knuckles, subnets, or network interfaces, as well as NAT gateways, all the configuration of EC2 and EBS, VPC endpoints, S3 buckets, security settings as key pairs or KMS, IAM policies, configuration of EFS and security groups. And regarding SAP resources currently supported, in terms of database, we automate and we support deployments on Oracle, SAP HANA, Sybase, and MaxDB. For sub-products supported are, of course, S4HANA, BW for HANA, all business suite, as well as NetWeaver ABAP and NetWeaver Java. And we are adding more SAP products, just like business objects, for example, to the automation platform to be available in the short term. And for the different deployment options, we allow or we are able to automate the deployment of SAP infrastructure on standalone or on a single node, as well as in distributed format in a multi-node deployment, and in high availability, which will be spread into in a multi-availability zone, and including the configuration of the high availability clustering software to automate the failover and failback of your SAP applications. So now it's time for the demo. I will hand over to Guillermo that will guide you through a small demo where we expect that we're able to show what we've been describing so far. So Guillermo.
Cool. Hello, everyone. I will try to show you quickly how the, I will try to share my screen first. I think that my screen can be seen now. So this is our first implementation of the NOAA console. We're working on an improved console, but this is what we use for the internal projects to be done within LinkedIn. Here we have the implementation of what is done in the background with Terraform. And for this little demo, I've created a small project for for an account that it's a linked account for demos, where we will deploy a small VPC with the minimum requirements that we use to perform some of the POCs or demos for our customers. As you can see, the only thing that we do is to attach an AWS account with an AWS IAM role that we have created previously that account, and with that, then we create some projects that we can separate infrastructure, security, SAP landscape, or anything that you want to deploy. This project we have previously deployed because it takes some time. Different AWS objects like VPC endpoints, not gateway, and private and public routing tables. And as you can see you can select the static data for that project. So you can create a VPC with a specific CIDR and how many availability zones do you want to use, and everything, and this information will be used for the deployment. What it really helps us with this approach is that then once we have created a VPC and all the resources that we need in that VPC, and we have tested that everything is working properly or everything is as we want that to do, we can clone the project, we can attach it to another AWS account, and we can redeploy everything in the same way in as many AWS accounts as we want. So in a customer perspective, we can create the development infrastructure, and then if you want your infrastructure to be replicated in the quality and production or even sandbox accounts, you can do that just cloning that project and changing the static data. Again, this is the resources that we created, and after that we have what is called NOA. NOA is the internal name for our SAP Automation Platform, and you can use the planning option to test that everything is configured correctly before you start deploy them. And then you can apply the infrastructure once it is checked. And after that, if you want to destroy it, if you don't want to have anything in your AWS account for security reasons or whatever, you can destroy all the infrastructure just in one click. I've created for that testing a second project for security. Here you can see that the resource list is in blue, so it means that it has not been already deployed. So here we have a security group, an EC2 instance, an IAM policy, basic data. And also then in the static data, you can choose the AMI that you want to use. This is a list. You can add additional AMIs to that project. And then you have the instance type. What policy do you want to create? You can upload policies that you have locally to that project, the subnet, everything, and you can import that data from the previous created project or from the VPC. So you don't have to add it manually. You can import the data and then deploy it again. And just when you have filled the static data, then you can go to a node worker, and to make it short, I will apply directly in our VPC, and you can see this in queue, and everything will be created automatically. What we do for our customers is we have another project that is the SAP landscape. So we will, in that project, we will create the instances and the names of the host names, and in which subnet do they want to reside, the security groups for the SAP. And everything will be created also automatically using Terraform. Terraform, that's the tool that we choose to create all the AWS infrastructure. Then you can, then we have Chef, as Ricardo said, for the SAP systems deployment and operation. I will let, that's a demo. that's a daemon error. You can see that this demo has errors. It's still working, so maybe it will deploy the infrastructure because it has some retries and it has to change some code and everything is done in the background. But this is a quick view of what we use, the tool that we use to create a new environment. And what we have in the other side. In the other side, we have the compliance. Once we have deployed the systems, the VPC, the AWS resources, and the SAP systems, using AWS and Chef, we can use, as we use Chef OpsWorks in AWS, that it's a console that allows us to check if everything that we have deployed in the AWS landscape is correctly done. So here, this Automate is attached to another AWS account from Linked that we use to create different scenarios for POCs or demos. And here you can see that we have done several deployments for the Red Hat high availability application server. We are working on a solution to orchestrate and to automate the orchestration of the high availability for SAP. And here we have a failed system. What we have with this is then we can check the errors. Why does this software fail? We have an error saying that for some reason the software failed. And also we have the compliance side. And what we have in the compliance side is that we can check the results based on policies, in this case, policies that have been created by Linked, using Inspect, that is another tool of Chef, where we can see what we preset the requirements for a compliant SAP high availability server to be installed, and then we can check what has failed in this deployment. We can see that in the SAP ABAP instance, some kind of processes like that reason we have a seeded AVM that it gets blank, so we fail to add some data during the deployment. But also we have the red cluster. The corosing process for the Red Hat cluster was not installed, so it was a failure during the deployment. And we can see another fail that we have during the testing. What's a good thing for that? That we can change that problem, then we can fix them. We can redeploy the same infrastructure just changing that deployment, and then we can use that policy and also the inspect policy for the compliance later to do it as many times as we want in as many customers as we need. That's a very quick approach of what we use to work with as DevOps in Linked. And now I will allow Ricardo to show you some other things.
Thank you very much, Guillermo. So hopefully through the demo you've been able to see components of the SAP Automation Platform at Linked that can be used as an example for inspiration for other customers to set up their own automation environment for their SAP infrastructures. We'd like to share some implementation tips where to start. We see from different customers that trying to achieve a full 100% automation for the SAP environments can be a difficult or big task, hard to accomplish. But we like to say that the cloud, the cloud offers us much more than just infrastructure as a service for our SAP environments, and doing DevOps can allow us to work much better. And we can start, we recommend customers to start with setting up a work environment and get trained on their teams, get trained on how to code your infrastructure. We find many customers that their system administrators don't know how to work with Git or how to represent in source code some parts of the infrastructure. So get the training there in order to be able to start working on the environment. Of course, choose your own toolset for automation, whether it's a third-party toolset or your own toolset, or a mix of both. Choose your toolset and set up the basics of the toolset that you need for your automation. And start small, iterate, and grow from there. As you've seen in the demo, using the approach with the compliance engine as an example, we can set up a predefined set of checks of validations that we want our infrastructure to comply with, and we can set up these checks, run those checks against our infrastructure. We get the feedback from our current infrastructure to see what servers or what systems are succeeding or failing in the tests. From there, we can work on the small automation pieces that will allow us to correct those checks, then work through our pipeline to develop, test, validate, and deploy those changes to those specific checks that we built at the beginning, and then monitor again and ensure that all the changes have been applied correctly and that our checks are all succeeding at the end. And have this wheel of and iterate and work over and over again with more and more checks, starting with the simple checks that can be, for example, checking file permissions or OS packages installed on your systems, up to much complex settings, maybe regarding EBS disk layouts or high availability cluster or availability of services and so on. Little by little, you can grow your checks and build your automation based on the checks that you are setting up. And these can help you get started fast, easy, and allowing you to build on solid steps and evolutions on top of your infrastructure. So wrapping up a little bit, all that we talked about in the past few minutes, we like to say that AWS offers much more than just elastic infrastructure. You have a very broad set of services and automations that allow you to do DevOps and manage more efficiently your infrastructure. We hope to have shown you and explained you that thanks to DevOps and using DevOps for your infrastructure on AWS, your IT teams can focus on more tasks that give more value to your business. They can get relief from manual, low value and repetitive tasks thanks to automation. This can help increase the efficiency and reliability of your SAP infrastructures thanks to automation, thanks to testing, thanks to compliance, thanks to standardization of your infrastructures. And of course, it will help you reduce costs, especially operation costs of your own infrastructure, which will give you a much faster time to market and time to deliver your changes as an IT department for your business. And of course, our recommendation is start small, set up your tooling, get trained, and start iterating one after the other and start building your automation for your custom SAP environments. Of course, you can You can start from scratch, or you can rely on our SAP Automation Platform, which we will give you an already built-in set of automations that will help you start and get up to speed in a much faster pace. So thank you very much. Now we're open for questions from the audience. So we'll wait a couple of minutes to see if there is any question from the audience. All right, so looks like we have a question from the audience. We're reading, what is your migration approach from on-premises for SAP instances? Well, to answer that question, let's say, first of all, we have to analyze the on-premises platform of your SAP instances, whether they are compatible or not with AWS instances. So especially if you have a HP UX, IBM X, or Solaris Spark platform, which are not compatible with x86 platforms in the cloud, we need to have a look into that to see how we are planning the migration, whether we can, well, usually we rely on SAP tooling like R3 load, and we do full database export and import into the cloud. When doing the migrations, what we tend to do is use the automation platform to build from scratch the future landscape you'll have on in the cloud, migrate, and once you start migrating, then start operating using DevOps, your infrastructure based in the cloud. Okay. We have another question from the audience. Does your automation platform also deploy your auto-scaling and backing solution? The answer is yes. With our automation platform, we do have included the setup of the auto-scaling solution and the memory backup solution for doing backups of SAP HANA databases. Another question, is your NOAA solution what we can get with a YAML configuration file? No. I'll let Guillermo answer that one, which is a bit more technical.
No, it's an orchestrator that is deploying in our in a Linky account, so you can rely on us in case that you want to deploy. Everything is secured. Everything is we only ask for the needed permissions to deploy the instance, and after the infrastructure is deployed, we can remove that role, and then we lost the access to your account. But this is an orchestration that has some lambdas, APIs, and something, then and other objects that for now we are not able to deploy it automatically and offer that to the customers. But it's something that can be replicated in case that it's needed.
Okay, we have another question from the audience. It's, are your Terraform and Chef Code repos publicly available or available at all to customers who purchase your solution? Well, they are not publicly available. Customers can purchase access to the SAP Automation Platform for the SAP environments, or they can choose to have access to the repos to feed their automation platforms in their own environments. We have another question from the audience saying, what about security management and NOAA tool security itself? Well, first of all, the way we connect from our SAP Automation Platform to the customer's AWS account or infrastructure is based on IAM roles. So actually there is it's the customer that sets up this security role, this IAM role in its account, and defines and controls there what the SAP Automation Platform will be allowed to do in its AWS account. Of course, we enforce and we ensure that we get the minimum permissions and requirements to operate and manage. That's a mandatory thing. And also in terms of our own NOAA security settings, our environment is relying on a let's say independent AWS environment, which is secured, which is using encryption and for storing all data and data transfer, and we are enforcing the security and of our platform on a regular basis. So we have another question from the audience. So how do you manage patching of SAP instances in AWS? Well, I'm assuming the question is around using automation, using the automation platform. With our automation platform, what we manage regarding patching is patching of operating system level, so operating system patches, database patching, and SAP kernel patching. Focusing on the SAP kernel part, through our automation platform, we can set up the change, the application of a new kernel upgrade, and automate the deployment and switch of the kernel, the SAP kernel software on the different SAP instances. This we are rolling. Well, we first build the automation for applying the new kernel, then we deploy it into development environments, we test and validate, and then we move forward through the pipeline through quality and production. I have another question from the audience. Have you tried deploying SAP HANA in cluster? I'd say we have deployed SAP HANA in with a SAP HANA replication in between different availability zones and between different regions. Also, we have deployed SAP HANA in scale-out mode, so it's multiple nodes for a single SAP HANA database, where one node can act as primary role and another node can act as a shadow instance for high availability. And we are supporting all standard SAP HANA deployments as they are offered with SAP. We have another question from the audience. What technology or architecture is used for your high availability solution for SAP? How is the NQ server and HANADB protected with your solution? Okay, this might be a matter for a much deeper conversation than the time we might have now, but I will highlight that our high availability solution is built as a serverless application on top of AWS services. So we have some CloudWatch alerts and some AWS Lambda functions that will monitor and control the status of the different SAP application layers, or database, SAP application, and NQ server, and central services instances. And when a failure or a CloudWatch alert is generated for each of these components, we apply some Lambda functions that will orchestrate the failover and failback of the application. This failover and failback, we are relying as well on SSM documents in order to do the proper actions in the different AWS environments. And specifically on how is the NQ server and HANA database protected, I will hand over as well to Guillermo, which can get into more technical details about it.
Well, about the HANA protection with our high availability solution, it is the same as any other approach of any cluster, but it is totally based on AWS services. As Ricardo says, we use different metrics stored in CloudWatch to check that the system, but both the instance itself, the HANA database, the EBS volumes where the database is running, or even if the operating system has errors, we check all of that and send the data to CloudWatch to respond in case of a failure. And using, as Lambdas and SSM documents and more, we are able to fail over the database to the health node in order not to lose any data during the process.
Okay. So we have no more questions from the audience. We're going to wait 1 more minute before closing the webinar to see if there is more questions waiting there. Okay. We see no more questions from the audience. So thank you very much for joining us today. We hope that you find the webinar useful, and we look forward to seeing you in future webinars as well. Thank you very much. Bye-bye.